All right, so moving on to section 11.2. We have been solving systems of equations with two variables and two equations. Now we're going to look at systems of equations with three variables, and we're going to take three equations at a time. You may have heard before that when dealing with systems of equations, there's a sort of general rule that if you are going to have any hope of finding an independent system with a unique solution, you have to have at least as many equations as variables. So got three variables, x, y, and z, and you better have at least three equations if you have any hope of finding a unique solution. With only two equations, then you might be able to find a dependent solution with infinitely many, but you won't have a single point. And this sort of geometry like demonstration of what's going on with the graphs of these equations should hopefully demonstrate why that is the case. So I explained in one of my early videos that if you have an equation of three variables, then its graph is going to be some kind of surface existing in three-dimensional space. In particular, with linear equations like these ones, the graphs are planes, flat planes, not necessarily horizontal, but they're flat. So this is the graph in 3D space of the equation x plus y plus z equals 3. It intersects x, y, and z axes, all three of them at the number 3 on each. So there is a plane. If I stick a second equation in here, there's a second equation. That purple plane there is x plus 3y plus 2z equals 14. And those two equations are intersecting one another along a straight line over here. You can see this straight line right there. So far, those two have infinitely many intersection points. So if I introduce a third equation with a third plane, now you can see that if I want to find a solution to all three of those equations at the same time, it has to be a point in 3D space which lies on all three of those planes. And that would be just this point right over here. So I can kind of zoom in and out, move around a little bit. And the point I'm looking for is this one right over here. I'm kind of trying to show it from a bunch of different angles. It is that point right there where all three of those planes intersect. And so I've plotted that point so you can see it. There it is. There it is right there. And so we're gonna go over in another video the algebra that you could use to solve this system of three equations and get that solution. So let's look at another one. So here's a second one where we have plane, plane. Okay, there's two planes, and they seem to be intersecting along this line that's kind of down underneath. By the way, this gray plane just shows the xy axis plane. So that's just kind of for reference. It can be easy to get kind of confused when you're moving around 3D space. It's easy to get disoriented. So there's the third of the three equations graphed, and you can see these three planes all seem to sort of meet along a single axis. This kind of slanty line, all three meeting each other along that line. So it's kind of like a fan fanning out or something. I don't know. But in this case, there's no single point, which is the intersection point of all three planes. Instead, we have infinitely many. So this is a dependent. It's going to be a dependent system of three equations. And then one more, you can guess what's coming. This is going to be an example of an inconsistent system of equations. So here's three planes that are kind of, they're all missing. Well, they don't miss each other. They all intersect each other pairwise, which means if you take any two of them, they intersect along a line. But those three lines that form the intersections of pairs of planes, they're all parallel to each other. And those three lines never meet. So we end up with the situation where there's no single point which is on all three planes at the same time, which is kind of like having parallel lines in two-dimensional space which never meet each other. So that's a situation where there's no solution. So we're gonna, in the next few videos, I'll go over these three examples from the algebra perspective, actually working with the system and trying to solve it, and we'll see what happens in each of the three cases.